All right, hey everyone. So this video is going to walk us through what do we do when we find extraneous solutions. So what is an extraneous solution, and then what do we do when we solve and we get an extraneous solution as one of our answers. And so remember, your goal here is to ultimately solve for x, and in order to do that, you need your radical on one side and everything else on the other. So in this example, we already have that, right? Our radical is here. It is the only thing that is on that right side. So we can start by getting rid of that radical by using inverse. So remember, taking the inverse means just doing the opposite, and the opposite of taking the square root of something is to square it. Okay, remember, whatever you do to one side, you have to do to the other side. So this leaves us with x plus 1 squared on my left side, and that turns into x plus 1 times x plus 1. And on my right side, squaring it would get rid of that radical. And so you're left with 2x plus 5. And so now when I solve, I need to get x on one side. And so I have x in a bunch of different places. So let's start by FOILing out or distributing out on our left side. So this leaves us with x squared plus x plus x plus 1 and 2x plus 5. And so this leaves us with x squared plus 2x plus 1 and 2x plus 5. And so remember, you want to solve. And so the only thing that we could do to solve here, we have an x squared there, we have an x on the right side, we have 2x. I'm going to bring these pieces here over to this side. So I'm going to subtract 2x minus 5 minus 2x minus 5. And it gives us x squared. These cancel out, so you get x squared minus 4 equals 0. And so when you factor on your left side, you're left with x plus 2, x minus 2 equals 0. And your zero product property tells you can separate them. So you got x plus 2 and x minus 2. And so x is negative 2 and x is positive 2. And so those are our two solutions, okay? It's really important that you always substitute or check your solutions. So substitute them back into your original equation. So I'm going to do that here. Here are my checks are going to go on this side. And so I have x plus 1 equals the square root of 2x plus 5. And I'm checking two different solutions. So I'm just going to do it twice. And so I'm going to substitute here the negative 2. So I have negative 2 plus 1 equals the square root of 2 times negative 2 plus 5. And so this is negative 1 equals the square root of 1, right? Because this goes from negative 4 plus 5. So negative 1 equals the square root of 1. So negative 1 equals 1. And this is not true. So this is an extraneous solution. It's a solution that you get when you solve. So you did all the math correctly to solve, but it actually doesn't end up being a solution to the original equation. So when you substitute that back in and this happens here, then that's what tells you that it is an extraneous solution. Okay, and so I'm going to do the same thing over here. I'm going to use the other solution, which was a positive 2. So 2 plus 1 equals the square root of 2 times 2 plus 5. And so this is 3 equals the square root of 4 plus 5. So 3 equals the square root of 9. And so this works. Okay, so our left solution, which is the negative 2, is an extraneous solution. When I substitute that back into my original equation, it does not work. It does not give me a true statement. However, when I substitute the 2 in, it does give me a true statement. So my solution is really just x equals 2.